Good afternoon, all. So, am I audible?
Yes, ma'am.
Okay, we are going to start the session within 3 minutes. Okay, let's start the session. This is week 4 Microelectronics Device to Circuit. This is the problem solving session. I'm Arpita Biswas, a PhD scholar from Electrical Engineering Department from IIT Jodhpur. So, this is more details about me. So, here we are going to solve some of the numericals and the MCQ question. And please try to go through the lecture already shared as shared in the class. So let's start the session. So this is the question number 1. Calculate the threshold voltage of the NMOS transistor shown in the figure below. Consider the ID equal to 1 milliamps, R1 equal to 100 ohms, and VT0 equal to 0.8 volt, and twice of phi f equal to 0.7. And gamma is given, which is 0.4 root over V. So please try to solve the question. And please, all of you, at least try, then I will solve. Is my screen visible?
Yes, ma'am.
Okay, try.
Good afternoon.
Yes, good afternoon. What is the answer?
And 0.92.
0.
0.9.
0.9. Please carefully calculate it. Can you explain how you have calculated the VTH value? Tell me what is the formula, how to calculate this VTH?
Ma'am, VTH equal to VTD plus sigma root of Q5 F plus VSB minus C root of Q5 F, ma'am.
Yes, VTH 0 plus gamma, then gamma into root over twice of 5 minus VSV minus root over twice of 5, right?
Yes,
Then tell
ma'am.
me,
Yes, ma'am.
yes, what is the value of VTH 0? It is what? 0.8.
0.8, ma'am.
Yes, 0.8 plus
0.8.
what is the value of gamma? 0.4, right? Then just put
Yes,
all this
ma'am.
value, like twice of 5 value is given, minus what is the value of VSV? At first, tell me the value of VSV. Because root over twice of 5 plus, I think, plus VSV and or mod of VSV you can take. So what is the
Yes,
value
ma'am.
of
Getting to.
VSV? Tell me. The main thing is you have to find out the value of the VSV.
Ma'am, 1 volt.
1.7, ma'am.
How you have calculated? Is this value is given like VSV value?
Ma'am, I have calculated 2.5 FB plus VSB 0.7 plus 1 plus 1.7 million.
Tell me again, what is the value of this VSB? How you have calculated? Just see. Tell me, is it right or wrong? Okay. So at first you have to calculate this VSB or VAs. Just calculate it. ID into R1. ID into R1. Okay. So what is the value of this ID? ID is given 1 milliamps. 1 into 10 to the power minus 3 into R1. What is the value of this R1? R1 is 100, right? Then tell me what is the value of this VS? It is 0.1. Like the substrate voltage is VAs, like the source side, it is this 0.1 volt. Now tell me what is the value of this VASB? Like source substrate to I think body, right? So, sorry, source to body. What is the value of this VSB? Here, see, one voltage is given. So 0.1 minus 1, right? Are you getting it? Hello?
Yes, ma'am. Yes, ma'am.
Is it like, I think 0. Like VSB, if it is 0 point minus 0.9, okay? So here you can write the formula, the VTH, the threshold voltage of the MOSFET equal to VTH 0. Tell me the equations. VTH 0 plus
VTH 0 plus gamma
gamma into root
root
over,
of 2 into root over 2 phi f plus VFB
yes, twice of
phi
phi
of
f,
phi
phi
f
f, twice of phi f, then
plus VFB, ma'am.
yes, plus VSB. But here it is in minus, so you have to take the mod. Okay, just here you can take the mod, like mod of twice of phi f, then the just directly put the value of the VSB. Then VSB, what is the value of this VSB? Just remove it. Minus 0.9. Minus 0.9. Why I'm taking this mod? Just because twice of phi f is equal to 0.7, then minus of 0.9. So this value is negative. That's why I have taken the mod. Okay. Then minus, this is the root over mod of twice of phi f minus 0.9 minus 0.7. Now tell me the value of this weightage. Tell me what is the value. Just calculate it. This VTH equal to VTH 0 plus gamma into root over twice of phi f minus 0.9 minus 0.7, and twice of phi f equal to 0.7. So VTH plus gamma. So what is the value of this VTH 0? It is 0.8 plus the gamma value is 0.4 into root over 0.7 minus 0.9 minus root over 0.7. So tell me what is the value of this VTH?
0.64, ma'am.
Yes, 0.644.
640.
Volt. So this is clear, all of you? So which option is the right option? Is the option C, right? 0.4 volt. So it is clear that how we have calculated this VSB value. Like here is a drop, like 1 volt, okay? And you have to find out the VS value. Then VSB equal to VS minus VB. So it is right 0.1 minus this 1 volt. So it is minus 0.9. And here we have take the mod value. So is it clear?
Ma'am,
Yes.
in question they are given gamma is equal to 0.4 into V power 1 by 2. What does mean the V power 1 by 2, ma'am?
V to the power 1. This is the like this is the V into like unit.
Okay, ma'am.
This is the unit. Okay. So
Okay, ma'am.
0.4 is the value. Just directly put this value, and this is the unit.
Okay, ma'am. Thank you.
So this is the question number 2. It is given that mu p is equal to 0.4 into mu n. What should be the relative weight of the PMOS and NMOS WP by WN if they are to have this equal ID? So what is the condition they have equal ID for PMOS and NMOS? And you have to calculate this WP by WN. Okay, and when operates in the saturation region. So this is another condition. ID is equal for both MOSFET and NMOS, NMOSFET and PMOSFET, and both are in saturation region. With the overdrive voltage of same magnitude, consider the both device have a equal channel length. So channel length LP and what are given here, and LN is same. Channel length is equal, and ID is equal. IDN equal to IDP, right?
Ma'am, excuse me, ma'am. Ma'am,
Yes.
ma'am, if the answer is 2.5 only, ma'am, something.
Yes, answer is 2.5. Good.
Okay, thank you.
Huh. So this two condition is given here. Now tell me how to calculate. Others also. This two condition is given, and another condition, this mu p equal to 0.4 into mu n. What should be the relative weight of the PMOS and NMOS? WP by WN. You have to find out this answer.
Ma'am, can I say that?
No, wait for others also. I know you can. Okay. So, other students, how to calculate it? Manoj?
Ma'am, this is the formula for saturation ID, ma'am. For ID is equal to 1 by 2 mu COX W by L into
Hmm.
VGS minus VTH whole square, ma'am.
Okay.
And the VGS minus VTH is also known as the overdrive voltage.
Hmm.
So we can directly substitute that for both the conditions, and we
Hmm.
canceling and equating both the current, we
Hmm.
can get the value, ma'am, by substituting all other values.
Yes. So first, this condition is given like ID N MOSFET equal to ID P MOSFET. So just put all this value like ID N MOS equal to ID P MOS. Others students also, Jane, Jasmine, Hari, please try at least this P MOSFET like P MOS. So tell me what is the equation here? How to which if it is in saturation, what is the equations? Half of mu n. Tell me what is the equation here? Half of mu n COX
W by L into
W by
VO.
L. Yes, W by L is for N MOSFET. This is a N. It is a N MOSFET, and VGS minus VTH, which is called the overdrive voltage. V overdrive. I'm directly writing here the V overdrive voltage for the N MOSFET. Okay, square is equal to half of mu p COX W by L for P into overdrive voltage for VGS minus VTH for P MOSFET. Whole square. So what is the condition given here? L is equal, right? So this will be cancelled out, and this overdrive voltage also, right? So this will be cancelled out. Half is cancelled out, and this then the COX also, because both are in saturation, so COX also cancel out. So what is here? The mu n into W. W for n equal to mu p into WP. So we have to find out this WP by WN. So what is the value of this WP by WN? Mu n by mu p. So what is the value of this mu p by mu p equal to 0.4 into mu n. So mu n by 0.4 into mu n. So what is the value of this 1 by 0.4 equal to 2.5, right? So what is the right option here? Option B. 2.5. The right option is option B. Is it clear for all of you? Can we move toward the question number 3?
Yes, ma'am.
So this is the question number 3. The two types of device scaling are constant current scaling and constant voltage scaling, constant current scaling and constant channel length scaling, or option C is constant field scaling and constant voltage scaling, or option D is the constant field scaling and constant channel length scaling.
C
So
option, ma'am.
Option C, ma'am. Option C, ma'am.
yes, option C, the constant field scaling and constant voltage scaling. This is the question number 4. The CMOS inverter can be used as an amplifier when NMOS operate in linear region and PMOS operate in saturation region. Option B is the NMOS operates in saturation region and PMOS operates in linear. And option C is the both NMOS and PMOS operates in linear. And option D is the NMOS and PMOS operates in saturation region.
Fourth option, ma'am.
Both.
Both in which region?
Saturation.
Both in
Saturation.
saturation.
Yes, both are in saturation. Option D is the right answer. So next is the question number 5. An ideal inverter exhibit first dash input impedance and dash output impedance. So it is high high, or option B is the high low, and option C is the low or high, and option D is the low or low.
High, low.
Yes, high, low. So option B is the right option. In an ideal inverter exhibit high input impedance. Yes. And low output impedance. So next, this is the question number 6. Find out the optimal size of inverter A2 and A1 in the following inverter chain in the term of size of A1. So you have to find out the A2 and A3 value in the term of A1. Okay, and consider the input capacitance A1 to be C1 and load capacitance is CL equal to 27 of C1. So this is the option. First option A2 equal to 3 of A1 and A3 is the 9 of A1, and option B is the 9A1, A2 equal to 9A1 and A3 equal to 3A1, and option C is the A2 equal to 13A1 and option and A3 equal to 14A1, and option D is the 14A1, A2 equal to and A3 equal to 13A1. So please try to solve this question.
Ma'am, A2 is equal to
Okay. So yes, which option is the right option?
first option.
Okay, so let's wait for others also. They please try it, then I will solve here. So others also. What is the right option here? Jasmine, how to calculate it? How to find out this A2 and A3 value in the term of A1 and A1? Hari, how to calculate it?
The minimal delay occurs when each stage has the same stage effort. So C out by C in raised to power of 1 by n. I mean CL raised to power 1 by n. 27 raised to power 1 by 3, which gives 3. So each stage it increases by 3 times. So 3A1 and 9A1.
Yes. Good. So let's calculate it. So CLY C1 has to be evenly distributed across n stages. Distributed across n stages. N equal to 3 stages. So what is the value of this small f? Equal to root over root n to the power. This is f. Okay. So what is the value here? It is the value of this f. If it is 27. 27 and here is 3. So what is the value of this small f? Equal to 3. So how to find out this A2 value? A2 equal to f into A1. So A2 equal to 3 into A1. And what is the value of this A3? F square into A1. A1. So this is 9A1. Okay. So is this clear? Hello?
Yes, ma'am. Yes, ma'am.
So this is the question number 7. For the inverter chain shown below, find the minimal delay through the inverter chain. Consider the self-loading gamma equal to 1, input capacitance of A1 to be C1 and load capacitance CL is equal to 27 C1. So find out the minimum delay. Find this minimum delay through the inverter chain. Tell me how to calculate it. So try how to find out.
Is the option C only, ma'am? 12 PP not, ma'am.
Sorry.
If the answer is C only, ma'am, C option only, ma'am.
Option C, yes, option C is the right answer.
Okay.
Okay, so wait for for other students. They are also calculating, I think. Then we will solve how to solve it. So tell me how to solve it. Jen, how to solve it? Hari, how to solve it? Tell me. Am I audible? Hello, Manoj?
Ma'am, explain the steps, ma'am. I couldn't
Yes.
understand. So,
Okay. Uh, who have already solved, please tell me what is the equation, how to solve this minimum delay. Hello.
N into TP naught.
Yes, what is the value of this TP? How to calculate this TP? What is the formula here?
N into
N into NTP0. NTP0. Yes, this is the N. TP0 into, tell me.
1 plus by gamma.
Yes, 1 plus root over, this is the N root of F by gamma. So just put all this value. What is the value of this N? This is 3, right? Then plus 1 plus, what is the value of this root over N, root over, sorry, root N of F? It is 3. And what is the value of this gamma? It is 1. So this is 3, right? And there is a TP0. So 3 into 4. Okay, this is the 12 TP and TP0. Is it clear?
Yes, ma'am.
Yes. So the right answer is option C. So next move toward the question number 8. In a CMOS inverter, increasing the PMOS width improve dash, but it also degrades. First option is the TPL, PHL, TPH high, and option B is the TPH, TPLH, TP, PHL, and option C is the VOH and VOL, and option D is the VOL and VOH. So which one is the right answer? Tell me what is the right answer. Am I audible? Hello, Jen?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
In a CMOS inverter, increasing the PMOS width improve dash, but it also degrade dash.
Is it option 2, ma'am?
Yes, option B is the right answer. Can you little bit explain?
Increasing the width increases its strength, so it reduces the TPLH.
Yes, it,
Um,
by causing a large parasitic capacitance, because as you go on increasing the PMOS width, right, then PMOS itself might be doing very good, but it will start loading your external load capacitance. Okay, so this TPHL is degrades, or it improves the TPH high. Okay, so option B is the right answer. This is the question number 9. Increasing the fan out of a CMOS inverter dash propagation delay. It increases, decreases, or does not affect. And option D is the decreases exponentially. Increases the fan out of a CMOS inverter dash the propagation delay.
Ma'am, increases the propagation delay, ma'am.
Yes, increases the propagation delay. Good. So this is the question number 10. A fast CMOS inverter can be made by keeping. First option is the high output capacitance. Option B is the low output capacitance. Option C, high on resistance. And option D is the low input impedance.
Low output impedance, ma'am.
So a fast CMOS inverter can be made by keeping low output capacitance and decreases on resistance of the transistor. Okay.
Ma'am, option B, ma'am.
Yes, low output capacitance. Yes. Low output capacitance. A fast CMOS inverter can be made by keeping low output capacitance and decreasing the on resistance of the transistor. So the right option here, option B. So next question number 11. The body effect in MOSFET primarily causes increases the channel length, reduction in drain current. Option C, increases in threshold voltage, and option D is the reduction in oxide capacitance.
Ma'am, option C, ma'am. Increases in threshold voltage.
Sorry, which option?
C, ma'am. C, ma'am.
Yes, increases the threshold voltage. Right. So this is the question number 12. The body effect modified threshold voltage is, the voltage equation is given here. Then if VTH 0 is 0.6, gamma value is given, phi f is given, VSB is given, then find the new threshold voltage. So please try to calculate this threshold voltage.
Option A, ma'am. 0.08 volt. Ma'am. Hello, ma'am.
No, it is. Hello.
Hello, ma'am. First option, ma'am.
How you have calculated this option?
Ma'am, I have taken VTH equals to VTH 0 plus gamma 25F plus VCB. VSB minus 25.
Yes, 0.6 plus 0.5 into root over 0.6 plus VSB. So what is the value of this VSB? It is 1. So 0.6 plus 1 minus root over 0.6. So just directly calculate the value. So check the calculation. VTH then plus root gamma into root this all portion. Just try at least again calculate it.
Ma'am, is it first option only, ma'am? Hello, ma'am.
Yes.
Ma'am, is it first option only, ma'am?
No, I think it is not first option. Just see the
Okay, ma'am.
calculation. Just check the calculation. I'm writing here the equation. This VTH I have to find out. Then VTH 0 is given, which is 0.6.
Ma'am, me also 0.84 the value getting, ma'am.
0.84.
Yes, ma'am.
Okay. Just see this calculation and tell me what you are getting. Then root over 0.6 plus 1 then minus root over 0.6. So tell me what is the value. This 0.5 is multiply with this all portion and this is additional. So what is the value of this VTH? Again calculate it. Others also, what is the value? Rajesh, Manisha? Like 0.6 plus 0.5 into this whole, it is when root over 1.6 minus 0. Root over 0.6.
Ma'am, we get 0.8 as well, ma'am.
0.8. Okay, then 0.8. Actually, I have not directly calculated it, but this is the how we have to calculate. So, what is the answer? 0.8.
Yes, ma'am. I got on with that.
Exact value is 0.84, ma'am. So nearest
0.8.
value is 0.8.
Okay. Okay. Then option A. But this in this way we have to calculate this value. The twice of 5f in plus VSB minus root over twice of 5f. So this is the question number 13. In a channel length modulation, the effective channel length is L, L plus delta L, or L minus delta L, or twice of L. What is the value of this channel length, effective channel length in channel length modulation?
C, ma'am. Option C.
Yes, option C, right? Next, if for the MOSFET saturation with the channel length modulation, the drain current is the given, and all these values are given. So you have to find out the value of this ID. So please try to calculate it.
Ma'am, I get 1.2 milliamps, ma'am.
Just a minute. Others also, have you calculated the value of this ID?
Yes, ma'am. 1.225 milliamps.
Okay.
Ma'am, 1.225 milliamps.
Okay. So how to calculate it? Just put the value. It's ID equal to half of what is the value of this mu and Cux? This is 200, right? 200 mu and Cux into W by L is given 5. Then the VGS minus VTH. What is the value of this VGS minus VTH? 1.4, right? 1.4 whole square into 1 plus lambda. What is the value of this lambda? This is 0.5, right? 0.05 into VDS. What is the value of this VDS? VDS equal to 5. So now tell me, after calculating it, what is the value? Hello?
Yes, ma'am.
Yes,
1.2, ma'am.
1.2.
1.2. Okay. So 1.2 milliamps. So next move toward the question number 15. In a constant field scaling, which of the following parameters is reduced along with device dimensions? First option is the voltage, then mobility, then oxide permittivity, or option D, doping concentration. Tell me what is the value, which one is the right option?
Option A, ma'am.
Yes, option A, voltage is the right option. So next move toward the question number 16. Which short channel effect reduces the threshold voltage with higher VDS? Punch through, channel length modulation, body effect, or DIVL?
Ma'am, punch through, ma'am.
Is it punch through or is it other option? Others also
Punch.
please at least try.
Sorry, ma'am. D option. Ma'am,
Others, no option, not option B. You can see. Always I'm giving the right answer. Is it not? You have to like cross check, right? So is it true or false? Option B is not the right answer. Please at least try. Which short channel effect reduces the threshold voltage with higher VDS? This is the DIVL effect, drain induced barrier lowering. You can cross check it. If you have any doubt, then you can cross check it. Is it true or false? Okay. So the right option is option D. So this is the question number 17. In a constant field scaling, all dimension and voltage reduces by a factor of alpha. If a MOSFET with L equal to 1 microamp, micrometer, voltage 5 volt, and Dux is equal to 20 nanometer, is scaled with alpha equal to 2, what are the new values? So these are the option. Find out the right option. Hmm.
option A, ma'am.
Yes.
Ma'am, option
Option.
A, ma'am.
Yes. Can you little bit explain how it is option A?
L is given as 1 microampere in a month.
The right option is option A. Just little bit explain. You are right.
Ma'am, L is equal to L by lambda, ma'am. 1 by 2 is the one, L is the 1 microampere and lambda is the 2, ma'am. Or it will be divided by 0.5, ma'am.
Yes.
0.5 microampere, ma'am. It will
Yes.
become. Then
So
V dash equals to V by lambda, ma'am. Then 5 volt by 2. It is 2.7. Then we have to divide by d of the lambda, ma'am. 20 by 2. Then it will become 10 nanometers.
yes. Okay. So next, move toward the question number 18. If MOSFET operates in velocity saturation, which parameter becomes the independent of L? Drain current in saturation, threshold voltage, subthreshold slope, or body effect coefficient?
That's option A, ma'am. Ranging current in saturation.
Just so, what is the right option? Option A, right? The drain current in saturation. So this is the question number 19. Which of the following is not the short channel effect? DIBL, velocity saturation, pass through, or mobility degradation?
Degradation.
Yes, which one?
D.
Yes,
D
option
option.
D is the right answer. The mobility degradations. Okay. So next move toward the question number 20. If the lateral diffusion length xt equal to 0.5 micrometer and channel width is 10 micrometer and the oxide capacitance per unit area Ux is given, what is the gate source overlap capacitance? CGS 0 equal to, you have to find out. COX is given, W, and W is also, I think W width, yes, it is given, and XD is also given. So what is the formula and how to calculate it?
And C of into W into XD, ma'am. It is the formula for GF, ma'am.
Okay, so which one is the right option?
E, ma'am. Option A, 1.7.
1.7? Just a minute. So others also try, then we are going to calculate it. Okay, let's try. So how to calculate this CGS 0? The CGS 0, tell me the equations. How to calculate? COX into
CO into W into XD.
W into XD.
Into
XD. So what is the value of this COX? 3.45.
0.45 into 10 to the power minus 7.
Yes. 10 to the power minus
10,
7.
10 micron.
Minus 7. And what is the value of the W? This is the 10
10 micron.
micro. And this is in A, like, yes, 10 micro. 10 to the power minus 6. And what is the value of this XD? This is also in micro. So 0.05 into 10 to the power minus 6, right? Now tell me what is the value of this. Just multiply onto. Yes.
1.7
1.17.
Fermi. Term.
A farad, right? The unit should be a farad. So it is 1 point, like you have to cross check, it is 1.75 or 17.2. Okay. Tell me what is the right option? Like what is the value? Just calculate it.
1.72 mean.
1.72. Okay. Others, you are also getting the same answer? Can we move toward the next question? Hello?
Yes, ma'am.
Yes, ma'am.
So this is the question number 21. In the cutoff region of MOSFET operation, the total gate capacitance appears mainly as between the gate and drain, between the gate and source, or between the gate and body, and equally distributed between the gate source and gate drain. So what is the right answer?
Siemens.
Yes.
Between gate and body.
Yes, between gate and body. Sorry, this is 21. So the right option is the option C, between gate and body. The question number 22, if VDD equal to 3.3 volt and the ideal switching threshold voltage VM is what? Which option? How to calculate it? Tell me.
B option 1.3 volts.
Yes, option B. Like how to calculate it? The VM equal to VDD by 2, right?
Yes, ma'am.
Yes, the
UTD by
VDD by 2. So it is 1.65. Then the question number 23, if load capacitance CL is 20 if farad and effective resistance is given, VDD given, find out the propagation delay. How to find out it? Tell me the equations. Just try.
option D. Ma'am, option D, ma'am.
Just a minute. Right, question number 20. Yes, which option?
D option, DD.
Just calculate. I'm giving the equation like how to calculate. Tell me the how you have calculated this TP. What is the equation? 0.69
169 into the 5 into 10 to the power of 9. 10 to the
R
power 3.
into CL, right?
Yes, ma'am. PL, ma'am.
Yes. So what is the value of this 0.69? Because I have not properly calculated, just to know the process. Okay, 0.69 into R. What is the value of this R? It is 5 kilo ohm. So you have to find out it.
I think
5 into 10 to the power minus 3. Sorry, 10 to the power 3. And what is the value of this CL? CL is 20 if farad. Now tell me after calculating it, what value you are getting.
C
Tell me.
option.
Yes.
C option, 69 picosecond.
0.69 into 5 into 10 to the power 23 into 20. But tell me the value. Just
69 picosecond.
simply multiply it. Because it's a simple calculation, right? Just multiply the 0.69 into 5 into 20. Yes. 20 and then 10 to the power. Hello?
Yes, ma'am. Yes, 69 picoseconds.
Okay. So next, this is the question number 24. For a CMOS inverter, VOH and VOL is given, and VIH and VIL is given. Find out the NMH and NML. So try to find out it. I think in the previous class also we have calculated it.
You can say the equation.
Tell me what is the equation, how to calculate this noise margin low and noise margin high.
VOH minus VIH, ma'am. First equation.
Yes.
NMH minus. Then NML is equal to VIL minus VOL.
Tell me the final answers.
Option A, ma'am.
Option A, ma'am.
Okay. So option A is the right answer. So this is the question number 25. The propagation delay of a CMOS inverter is given, and equivalent is given for N and P, and CL is given. What is the average propagation delay? So find out the average propagation delay.
Ma'am, option B, ma'am. 103 picoseconds.
Okay, wait for 1 minute. Others also try. Then I'm going to solve it. So tell me what is the right answer. Hello.
Ma'am, B1. Option B, 103 picoseconds.
Yes, option B is the right answer. So how to calculate the TP equal to TPHL plus TPLH by 2. Okay. So this is the option. Right answer is 103. I have to calculate or you will calculate it. Just put the formula. This TP equal to TPHL plus TPLH by 2. This is the formula. You have to find out all these things. Okay, just 0.69 into R into Cl. Okay, just put all this value. So you'll get 0.103. So this is the question number 26. Each charging cycle of load capacitance in CMOS inverter stores energy equal to which option? So which option is the right answer?
Option A, ma'am.
Yes, half of Cl VDD. Question number 27. Given Cl equal to 25 farad and VDD delay is 60. So find out the PDP and EDP, the power delay product and the energy delay product. So find out. Just calculate by using the previous equations. Like PDP equal to half of Cl VDD square. Okay. And EDP is equal to PDP into TP.
BP is 56.25 farad and EDC is 8.375 10 to the minus 26 minus 24 joules per second.
What is the value of this PDP?
56.27.
I'm giving the equations. Just put the value and calculate it by own. PDP equal to half of Cl into VDD square. So half of Cl, it is 25. If farad means 10 to the power minus 15, right? Into VDD square. That is the value of this VDD 1.5 whole square. Just calculate this value and tell me the answer. And how to find out this EDP? EDP equal to PDP into TP. And how to calculate this TP? TP is given, which is 60, right? Just multiply this with this. So then just calculate it. Then we will move towards the next question. Tell me the value. What is the value of this PDP?
156.27.
Yes.
156.27. हम लोग को डेटा चाहिए नहीं
Whatever value we are getting this PDP, just multiply with this 60 PS. Okay. So next move toward the question number 28. So if the leakage current is
Ma'am,
yes,
27th question answer once again, ma'am.
just calculate it. Calculate the value.
PDP is equal to 28.12 F
28.12 yes 1 F J.
EDP is equal to 1687.5 10 power minus 27, ma'am.
Yes, it is 1686, right?
Yes, ma'am.
1686 F J into PS. Okay, so next move toward the question number 28. If leakage current is given 5 nanoampere and VDD is given 1.2, find the static power.
Ma'am, answer 6 nanowatts.
Okay, wait for 1 minute. Others also try to solve, and we are going to calculate it. So how to calculate this static power? Just multiply. Tell me what is the right answer. Hello?
6 nanowatts.
6 nanovolts.
Yes. So just multiply this I leakage into this voltage 1.2. So this is 6 nanowatt. So next move toward the question number 29. A load capacitance CL is 64 F farad is given by an inverter chain of 3 stages. Input capacitance of the first stage is 1 F farad and find the optimum stage sizing factor is F. So you have to find out the value of F. Tell me how to calculate.
Answer is 4, ma'am.
Yes.
Answer is 4, ma'am.
What is the value of this F? Like F is equal to CL by CN.
CL, CL, ma'am.
Okay. Then what is the value of this CL? It is
64.
64.
4 into 1 power 1
Then
by
yes, 3 stages. Then F equal to root over 3 into 64, right? So what is the value?
4.
4. So this is the question number 30. This is the last question. For a CMOS inverter, CL is given, VDD given, delay given. Find out the PDP, power delay product.
Ma'am, answer is 57.6 farad, ma'am.
Just put the value. Just a minute. Okay. So how to tell me how to calculate this PDP? What is the formula here? The PDP is
P
equal
average,
to,
P average into delay, ma'am.
okay, so you can also directly find out by like half of CL into VDD square.
Okay, ma'am. That is E average, ma'am. That is E
Okay.
average.
VDD square.
It is
So
plus.
now tell me how the value CL. So half of
CL is 40, 14, 10 to the minus 15
CL is 40
into 10 to the minus 15.
into, this is multiply, right? 40 into 10 to the power minus 15. I'm not going to calculate all the values. You have to calculate it. 15 to 10 to the power 15 into
Into 1.2.
1.2, right?
Yes, ma'am.
1.2 whole square. So tell me the final answer.
57.6 in 10 to the minus 15.
28 femtone.
Yes, 28.8.
28.8.
Yes, 28 point. Just see the calculation. You have to find out the calculation. I'm just given how to calculate it. All the values are given. You have to find out it. Okay.
Okay.
So we are ending the session here. Next we will meet next Tuesday, 7 to 9 p.m. Okay. So we can
Thank
leave.
you.
Okay.
Thank you, ma'am.
Okay.